Welcome students, this is your slope-intercept form video for 11/11/2014. We're going to start out with the Frayer model here, and I'm going to go and do each box slide by slide. Is the definition. The definition of slope-intercept form is that it is a linear equation written as y equals mx plus b. It's one of about 3 or 4 different styles of linear equations that we'll study throughout the year, and this is the most important one. It's the one that we refer to most often throughout the year. The key facts or characteristics about it: when we get it into y equals mx plus b form, it identifies some things for us. This m refers to our slope, and this plus b on the end here refers to our y-intercept. And y-intercept is kind of a new vocabulary word too. Y-intercept is where the line crosses the y-axis. This will be another vocabulary word that we can put in there. This is what the y-intercept looks like. If this red line is our line, then this is the y-intercept. Okay. We'll use this later on in the year to graph. When we graph, we start out, we plot the y-intercept, and then we count out the slope, up, over, up, over. And so we'll get to that a little bit later on in the year. Some examples of y equals mx plus b. Y equals 5x plus 2. Y equals 1/2 x minus 3. Y equals negative 5/3 x minus 6. You can even have decimals. Y equals 0.5 x minus 0.9. Y equals 2 is even in the form mx plus b. Before it became y equals 2, it was y equals 0x plus 2, and then the 0 disappears and becomes y equals 2. Some non-examples: 5x plus 3y equals 10, non-example. Y plus 2 equals 3x. X equals 9. 2y equals 6x plus 3. In all these cases, you can see that the y is not by itself on one side. Even this would be a non-example. Y equals 5x plus 9x minus 6. It's close. It is solved for y, but it's not an mx plus b form. These would need to be solved. Same thing for something like this. Y equals 5 parentheses x plus 6. Not in y equals form either, just because it has some simplification stuff to do. Alright, so we kind of gave you kind of a preview of this idea the other day, solving for y. And we're going to continue doing this because, like we said the other day, it's one of the most important things. Some of the things we listed the other day: number 1 reason is the calculator. That's why y equals is so important, because you can use the calculator. Number 2 reason is the whole y equals mx plus b. We're going to do so much with that this year that you really need to be able to get things solved for y. So here's some quick steps. Some quick steps to help us with solving for y. Number 1 is we always have to simplify. And by simplify, we just mean take care of your like terms and take care of your double rainbow. Okay, so if you see any parentheses or any multiple x's or multiple y's, you got to take care of those first. Step 2 is we put a box around y, and this was to remind you to leave y alone. Okay? We never want to start out messing with y. We want to leave it alone until the end. Okay? Step 3, if there's an x over there by that box, we need to move our x term by adding or subtracting. In step 4, we always finish up by dividing by the number in front of y. Okay, and if there's no number in front of it, then this step won't happen. Also, if there's no x term over there, that step won't happen. So steps 3 and 4 are just kind of their optional steps. If there's an x over there, then you have to move it. If there's a number in front of y, you have to divide by it. So those aren't absolutes. They won't always happen, but they usually do. That's why we include them in here. Alright, our first example. Draw my line down just like we did. I'm going to switch to a different color here just so it kind of looks different. I look at both sides. There's no simplification to do. 3x and 2y are unlike terms. 10 by itself over there. There's no parentheses in here, so I'm ready to move on to step 2, which is box my y. Right. Step 3 is move the x term away. We want to move this 3x away, so we subtract 3x. Remember we said to offset it over here? The reason we offset it because 10 and 3x can't be combined, so there's no reason to write them underneath each other. Bring down my 2y. This gets written as 10 minus 3x. Divide everything by 2, last step. Y equals 10 divided by 2 is 5. When I type in negative 3 divided by 2, math 1, enter on my calculator, it tells me to leave it negative 3 over 2x. Now this isn't quite mx plus b form. We need to move that negative 3 over 2x to the front, and that's a positive 5, so we move it to the back. And there's your answer. Okay, let's try. Here I would slip 1s in front of those. Draw my line down. No simplification to occur, no parentheses, no like terms, so a box. Get rid of a 1x by doing minus 1x. Offset it over here, minus 1x. That cancels out. Bring down my negative 1y. 6 minus 1x. When it's beside it, I divide it. So divide everything by negative 1. Y equals 6 divided by negative 1 is negative 6. Negative 1 divided by negative 1 becomes positive 1x. And again, I want it mx plus b, so the 1 has to go to the front. 1x. The negative 6 to the back. 1x plus 6. And the only thing you might see is you might not see that. The 1 in front of there. So it'll just be x minus 6. Alright, one more example, and we're going to continue. We're going to do lots of these in class, so you're going to get a lot of practice at it. Okay. Here, I draw my line down. I look for simplification. This one does have simplification, so I'm going to double rainbow here. So nothing over here. 2y equals 3 times x is 3x. 3 times a negative 2 is negative 6. Box my y. Nothing to move from around it. See how there's nothing over here? So I'll go straight into when it's beside it, I divide it. So I'm able to skip the move x term because the x is already on that side. So 2's cancel out. 3 divided by 2, math 1 enter, stays 3 over 2. Negative 6 divided by 2 is negative 3. And no movement on this one because it's already in mx plus b form. Okay. As far as mx plus b form, this is your slope. And this is your y-intercept. So if I were graphing this on a graph, 1, 2, 3, this line would cross down here. I know this has a positive slope, so it's going to go uphill something, so it's going to look something like this once we get further into it.